In this video, we are going to do some questions based on electricity. Well, the first question I have taken where it says that a current of 0.5 ampere is drawn by the filament of an electric bulb for 10 minutes. And what we have to find is the amount of charge, that is quantity of charge that flows through it. So let's recall the relation we have about the current and charge. Well, as for the definition, we know that current is what the rate of flow of charge is. So using this relation, I can say I is equal to Q, which is the quantity of charge divided by time. So what you can see that from this question, we have I given as how much? 0.5 ampere. We know the time here. Well, you can see the time is in minutes. So I'll write time as 10 into 60. That is equal to 600 seconds. So now we know the time here. So we can use this relation from here. What I can see by multiplication, Q is equal to I into T. So I, which is 0.5 multiplied by time, which is 600. So it comes out to be how much? Half of 600, that is 300. C stands for the coulomb, right? So this is the first question. Let's move to the next. The question here is name two special characteristics of this heater coil, right? As you can see, I've taken a heater coil here. So the two important characteristics that you should know about this coil are these two, right? Number one is this. The resistivity of an alloy is generally higher than that of a constituent metal. So because of high resistivity, right? When resistivity is directly proportional to the length of the wire, first of all, we'll talk about the resistance is directly proportional to the resistivity. So higher the resistivity, higher is the resistance, and so therefore the heat developed is fast and more. So using this relation that H is equal to I square RT, we can also say that heat is directly proportional. H is equal to I square RT. Heat is directly proportional to the resistance. So the first point you will be writing is that resistivity of an alloy is higher than that of its constituent metal. Second reason is that alloys does not get oxidized. Alloys does not get oxidized or does not burn at high temperature, and that is the reason why it is commonly used as heating devices. So these are the 2-point reason you will give to answer this question. The next question, you can see there is a diagram, and in this figure circuit diagram, you can see the resistance are given. Now let's put right down. The resistance of this first one, say R1, is given how much? 5 ohm. This as 10 ohm, and this as 30 ohm. Now what we have to find out is the current through each resistor. Now, first of all, you should understand that these three resistors are connected in parallel. And how did I guess? It's because like I just put a finger over here, I say. I'll just place a finger or hide this portion. So when I hide this, right, I see that the current supply on R1, on removing R1, right, on removing R1, the current continues to flow in R2 and R3. And same way, if I just put a place my finger over here to hide, we'll see that the current continues to flow on the other two resistors. So these three are connected in parallel, right? They are connected in parallel. And you know that in parallel, the current vary. That means we know that V is equal to IR. So from here I can say I is equal to V by R, but then we'll have different I. I1 will be V by R1 and so on for the other. So we have to get the current all these three resistors. So first I'll get V1, which is, I1. I1 is equal to V by R1, and V is how much? V is 12. So this is 12 over R1, and R1 from here is how much? Is 5 ohm. Likewise, it's I2 is V over R2 and R2 is how much? 10. And I3 is V over R3, and R3 is what? 30, right? 30 ohm. So this way we got I1, I2, and I3. Now say the total current. The total current is I is equal to I1 plus I2 plus I3. So I will be how much? That's 12 over 5 plus 12 over 10 plus 12 over 30. Well, this is your part to do it. Calculation. That should be in ampere. Now the total circuit resistance. Yeah, it's already discussed earlier that here the resistors are connected in series, right? We can see these three resistors are connected in series. So the total resistance in this case is what? 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So let's say if I do it here, 1 over R is how much? 1 over 5 plus 1 over 10 plus 1 over 30. Now I take LCM as 30. 6 times, 3 times, and 1 times. So 1 over R is equal to 10 over 30. So on reducing, it's coming how much? 3 ohm. Yeah, that's on reciprocating, right? So R comes out to be 3 ohm. Let me recheck again. LCM is 35, 6 times, 10, 3 times, 10, 31 times, 6 plus 3, 9, 1, 10, 10 divided by 30. Yeah, so we can now sum up the things that we have done. Number one is the total current from here, individual current, these three, the total resistance as 3 ohm. In this question, this is an electric lamp. This is a lamp, and whose resistance? So the resistance of this electric lamp is given, that is R over here is given as 20 ohm. And further it says, and a conductor of 4 ohm, this is a conductor of 4 ohm resistance, right, are connected to a 6-volt battery. Yes, this is a 6-volt battery. Okay, so we know V here. What else we are supposed to find out? Number one, yeah, let's calculate the total resistance of this circuit. So if I take the resistance of this wire, this conductor, say R1, and this has R2, what you can see that these two are connected in series, right? Why series? Because they are end-to-end connected. You can also test yourself in the exam that if you cover this part with your finger, any point in between, if you cover with this finger, you see that the current supplied does not reaches like that. This end of this conductor is connected with a positive, but the other end is not. And so for the other devices. So we get to know that they are connected in series. And to calculate the resistance in series, we have a formula. And what is it? That R is equal to R1 plus R2 plus R3. Well, there are two resistors only. So we'll say that the resistance here will be of 4 ohm from here, say R1 plus 20. So the resistance, the total resistance, which is also called as equivalent resistance, is 20 ohm. Done with the first part. Now the second part, it says the current through the circuit, right? So current through the circuit. Now look into this. The total current in this circuit is what we have to find out. So for that, we need the total resistance and the total potential difference. Now we will be using Ohm's law, that is using Ohm's law, which is what? V is equal to IR, right? So therefore, I is equal to what? V over R. So I can do here V over R. And how much is V? V is 6 volt. And over R, this is 24. 20 plus 4 is 24. So which is 1 by 4? 1 by 4 ampere. Or you can even write 0.25, right? 0.25 ampere. Now next is the potential difference across the lamp. Okay, we have to get V over here and V over here. This is important to remember that V is does not remain same in series as these two are connected in series. So we'll have different V over here. Let's say I use V1 and V2. So again, applying the Ohm's law, applying the Ohm's law, we can say that V is equal to IR. So V1 is equal to IR1 and not I1 R1 because I remains same in the series. So V1 is equal to I is where I is this over R1. And how much is R1? R1 is 4. So V1 comes out to be 1 volt. Now, same way, if I have to get V2 is equal to what? I R2. So I is how much? I is same as 1 by 4 as it is in series, and R2 is 20. So I'll get how much? 5. So V2 is equal to 5 volt. So we now can say that the potential difference across these two conductors, right? Say one is this, other is this. We have to get the current, we got the current, and we had to get the resistance. So we got the resistance also. In this question, it says a 4 ohm wire is doubled on it, and we have to calculate the resistance of the new wire. So let's understand what does it mean. It means to say that, let's say if I have a wire, let's say this was the original piece of wire, and it is doubled on it means what? It is folded from the middle and is placed over it. That's what they mean. So from here you can conclude what? That let's say if the length of the original wire was say L, the new length as you can see from here is half. And if A is the original area, as you can see that the area of cross section is what? It's being doubled here, right? Now we are going to apply this relation that R is equal to rho, which is the resistivity, L for the length, A for the cross section area. So let's say the resistance of the original wire, which was given as 4 ohm, and the resistance of the new wire is what we have to get. Now we are going to say R dash will be what? Rho is not going to change as it is the same wire. As far the length is concerned, length is now double its original length. So I'll replace L with L over 2 divided by, now the new area is 2 times, so it's 2A. So I can simplify this. Let's rho be rho. L by 2 dividing is same as multiplying with the reciprocal. So the new resistance, I can see it's 2 into 2, 1 over 4 rho L over A. And this is how much as for the question? This is how much? This is R, and R is 4 ohm. So now I can say that the new resistance of the wire, say R dash, will be 1/4 of the original resistance of the wire, which is 4 ohm. So this get cancelled here, and the new resistance is 1 ohm. This is omega, right? The sign for the SI unit of ohm. In this question, it says two wires of equal length, one copper and the other is manganese and alloy, right? Having same thickness, which one can be used for electrical transmission and for electrical heating devices? Now let's first understand the relation here that the resistance of a wire, right? Resistance of a wire is directly proportional, or say if I write down the direct formula here, R is equal to rho L by A, it means L is directly proportional, resistance, sorry, R is directly proportional to the length, it is inversely proportional to the cross section area, and it is directly proportional to the resistivity. Now, first thing is the wire of equal length, right? So the length is equal and same thickness. So ultimately, it is the resistivity on which the resistance will depend here. Now, what you can see that the copper wire from here, if I show you the copper wire, look into this. copper wire has a very low resistivity, right? So it's a good conductor, right? So lower the resistivity, high is the conductivity. One more time, current is inversely proportional to the resistance. Using this relation, V is equal to IR, Ohm's law. So lower the resistance, higher the current. Now what you can see, the low resistance is produced for a wire having low resistivity, right? So what you can figure out one more time, that this copper wire has a very low resistivity, so it should be used for electrical transmission. And manganese, right? Have I taken this? Yes, it is here, right? You can see that manganese has a very has a higher resistivity, right, than that of the metal from which it is made, and therefore you can figure out from this that this wire should be used for heating devices. Reason, it has low resistivity. An additional point you can add on that this is an alloy, and alloy has a it does not oxidize at high temperature, and that's why it is used for electrical transmission. Too many arrows. I think you got it. In the next question, as you can see, a figure is given, a circuit diagram, in fact. And the question says a child has drawn the circuit to study the Ohm's law as shown in the figure. And the teacher told that the circuit diagram needs correction. That means circuit is not correct, the diagram. We have to examine the circuit diagram and suggest the correction. Well, what you can observe over here that this is an ammeter and this is a voltmeter. So ammeter is always connected in series and voltmeter is connected in parallel. So this is what the correction needed. That means this should have been a voltmeter. As you know, voltmeter should be connected in parallel, and ammeter is always connected in series. So this should be the correction in this case. Other things, as I can see that rest are correct. As you know that the direction of current, there is another important thing that you should know, that direction of current is always taken from the positive to negative terminal of the battery. And as I can see, it is correct over here. The battery is also connected fine, and there is a switch, so nothing else. The only changes that should be made is about these two devices, that is ammeter and voltmeter. Ammeter is always connected in series, after correction I'm talking about, and the voltmeter in parallel. Let's move to the next question. In the next question, it says a wire of resistivity rho, right? This is not P, this is a rho, is stretched to double its length, and how does it affect the resistance and the resistivity? Now, for that, you have to recall the relation here, that is R is directly proportional to A and directly proportional to length and inversely proportional to the cross section area, or area of cross section. So let's say I took a wire, right? This was the original wire, and you see, this is the same wire, and now I'm stretching to double its length. As you are observing that as I'm stretching its length to double, its cross-section area decreases. Means to say, if this is wire L, so the new wire's length is 2L, right? And if the original wire has the area as A, the thickness will become half the original thickness. Now let's use this relation. What you can see one more time, that the new wire, say L dash, will have length as twice the original wire, and the new area, say A dash, will have the cross section areas A by 2. Now observe from here that R dash will be what? Will be proportional to L dash over A dash. So I can say R dash is what? A dash, L dash is what? 2L from here. And it's A over 2. Dividing by A over 2 is same as multiplying by 2 by A. So we can say that the R dash will be 4. 2 into 2 is 4. It's not equal to proportional to 4 over L by A. Now check here. This is what? This is, from here is R. So R dash will be 4 times, it will be 4 times the original wire. So we can now say the resistance will become 4 times. Now next is resistivity. Well, resistivity is a constant of proportionality. The resistivity of the wire does not depends on the length, nor it depends upon the cross section area. It depends upon the nature of material. Like a wire of a given material has the fixed resistivity. As you can see, it is the same wire. We are not changing the wire like from copper to nickel or say copper to aluminum. The resistivity will not change. One last time, resistivity of the conductor depends upon the nature of material. So the nature of material is what? If I take a copper, it has a fixed resistivity. If it is aluminum, it has fixed resistivity, and for other metals. So as you can figure out, the wire material is not changed. So we'll say that here no change, no change will takes place in this case. The next question says, in the given circuit, connect a nichrome wire of length L between the points XY and note the ammeter reading. Like I will be connecting a wire over here, right? A wire over here and will connect the ammeter reading. When this experiment is repeated by inserting another wire of the same thickness but twice its length, what are observed in the ammeter reading? So once again, the question is related to the length and the cross section area. So what you can see that the wire has the same thickness. So we'll be ignoring this aspect, this relation. We'll be focusing on this part that the resistance is directly proportional to the length. You can see that the wire initially was of L is now of 2L. That means we'll say that the new resistance will be double the original resistance. As you can see, resistance is directly proportional. But then you have to realize that we have to find out the ammeter reading. As you know that from the Ohm's law, we know that V is equal to IR, right? Ohm's law said V is directly proportional to I, but using this, we know V is equal to IR, so I can say I is equal to V over R. Now check here. Considering V to be constant, I is inversely proportional to R. That means higher the resistance, lower is the current. So as you can see that the resistance is being doubled. Sorry, the resistance, yeah, it's okay. That's clear from here. The resistance is being doubled. So the current will become half. One more times, use these two relation. Just let me highlight in what I'm talking about. Just look into these two relation here. In the first we can see that here the resistance is being doubled and the current is inversely proportional to resistance. So we'll say that the current will become half. The new current will become half of the original current. So we'll say that the ammeter reading will become half. Whatever is the original reading, now it will be half. In the next question, he says a figure given below with 3 cylinders. As you can see here in the figure, there are 3 cylindrical copper conductors along with their face area and the length. So by face area, they mean to say that this section of area, that is cross section area, that's what the face. And length is what we can see from here. The length is of L, this is of 2L and L over 2. Now, what we have to discuss is the geometrical shape having the highest resistance. So before we come to this highest and the lowest resistance, you need to remember the factors affecting the resistance. So what we know here that the resistance, the factors which affect the resistance are, as of now, I've taken 2. So one is the resistance is directly proportional to the length of the conductor, right? So it means to say that the resistance, say R, it is directly proportional to length. That means longer the length, more will be the resistance. And the second factor, it is inversely proportional to the area of cross-section area of cross-section. That means R is inversely proportional to the area of cross-section. Well, the first from here we get to know that longer the wire, greater the resistance, and thicker the wire, lower is the resistance. Or you can say thinner the wire, higher is the resistance. One more time, longer the wire, greater is the resistance, and thinner the wire, greater is the resistance. So from all this figure, we can see that the longest wire is this, and the thinnest wire is again this. So therefore, this will have the highest resistance. Yeah, we are looking for highest, right? So, and if I have to also, let's say, in addition to the question, if I have to look for the lowest resistance, so we can say the thicker the wire, lower is the resistance. So from here, we can also conclude that this wire has the shortest length. So we'll have the lowest resistance. Anyway, if I have to say, if I write X, Y, Z, or if I write X, Y, Z as the wire here, then I can see that the highest resistance will be in case of Y and the lowest in this case. So if I have to arrange them in the ascending order, I'll say the wire with the lowest resistance will be Z, then X, and then Y. That's how we will do this question. The question says a wire of given material having length L and area of cross section as A has the resistance 4 ohm. What would be the resistance of a wire of the same material and the length as A by 2 and the cross section area as A? Now let's figure out that the area of the wire, the new wire is twice the original wire, right? And the length which is made half, right? So the new length is half the original length. And the original resistance is given 4 ohm. What we have to find out is the new resistance. So what we know here that R is equal to, well, rho L over A. Well, A is the constant of proportionality. So the new resistance, the rho is not going to change as the material is not changed, but the length is not changed. The new length is what? L over 2. The new length is L over 2 and the area is doubled. So the new area, I'll replace A with 2 times A. Now, let's solve this. If I solve this, say the R dash, rho as I said is not going to change. This is what? L over 2 divided by a number is same as multiplying with the reciprocal. And if I write R dash, I can say this is 2 into 2, 4. That is 1 over 4 over here. And rho as it is. This is what we are left, L over A. So this is L over A. Now check from here that I can replace this thing. I can replace this thing. Yeah, this with the resistance, and the resistance is 4 ohm. So we'll write here 4, and we say that the new resistance of the wire is 1 ohm, and that should be the answer for this question. The question says a wire of resistance, right? Just a second. I have missed a symbol here. This is ohm. Okay, let's continue reading. What we know here that there is a wire of resistance 100 ohm is drawn out to its length so that its length is thrice its original length, right? And we have to solve and find the resistance of the new wire. So let's say if I take a wire, I took a wire. This is the wire, and I took its length, say, to be L, area as A, and the resistance, say, as R. Now check here. This is drawn to its double its length. Like this is the original wire, right? Drawn to its double, not double, sorry, thrice its length means what? It is stretched so that its length becomes twice of its original length. Now, one thing you can figure out that the length has become 3 times its original length, but at the same time you can see the thickness has decreased. And how much it should be? It should be 1/3 of the original thickness. As you know that when you stretch anything, say a clay, Its length increases, but its cross-section area decreases. Now we have to solve and find the new resistance. So what is the resistance given here as 100 ohm for the original wire? Now check here, we have to get the new resistance. Say I took R dash, and the relation which we should know that R is equal to rho, this is rho, resistivity L over A. Important is here the length and the cross-section area. So what I can do, let's say the material is not changed, so I'll write rho as rho, but the new length is what? It's thrice. So I will replace the new length here with 3 times L, and the new area, that is this A, I'll be replacing with A by 3. Now solving this, what we get? R dash, say this is rho only, it is 3L. Dividing by this is same as multiplying with its reciprocal. So what we get here? R dash, which is rho, it is 9 times L. 9 I'll write in the beginning. This is 9. 3 into 3 is 9, right? So this is 9 rho L over A. This is rho, that's rho L over A. And I can see this is equal to 100. So the new resistance will be 9 multiplied by 100. That should become 900 ohm. Technically, you should remember that this should be 9 times of the original resistance. This is a set of 4 questions. The first question says, on what factors does the resistance of the wire depends? So you know that wire, the shape of the wire is what? It is cylindrical in shape, right? And its cross section is in the shape of a circle, right? So we know that, let's say this be the length and this is the area, and the material, like the nature of material, the resistivity, which is rho. So we know that R is directly proportional to length, R is inversely proportional to area of the cross section, and R is proportional to L. That means the value of resistivity, right? So we'll club together and we'll say that depends upon the length, area of cross section, and the resistivity. The next one, now the second, right? It says, will the current flow more easily through a thick wire or a thin wire of the same material, right? Material is same, that means this is same, right? And when connected to the same source, okay, so thick wire or a thin wire, let's say, once again, you understand two things. I should first remove this portion. Let's focus on this part. Here it says that the flow of current, right? So first of all, you have to remember, recall that Ohm's law. So what is V is equal to IR, right? So keeping in this mind that V is equal to IR, I is equal to V over R. That means for the same source, and that means when V is constant here, current is inversely proportional to R, right? Current is inversely proportional to R. And from here, you can see that the current is inversely proportional to A. Let's do one by one. Thicker the wire, right? Thicker the wire, one more time. Thicker the wire, lower is the resistance, and lower the resistance, greater the current, right? One more time. Thicker the wire, lower is the resistance, and lower the resistance, higher is the current. So we'll say that current will flow more easily through a thick wire. Now let's move to, were more questions, right? So let's see what was the questions below. We are on third question. It says, let the resistance of a electric component, I'll read it. It says the resistance of the electrical component remains constant while the potential difference across the two ends of the component decrease to half of the original values, what will happen to the current? Okay, that's based on the formula V is equal to IR. Okay, so resistance of the component remains constant. So R being constant, V is directly proportional to I. Right? And what they are saying that what will happen to the change in current if the potential difference of the two end is half? So that's very easy. They are directly proportional. So if I reduce one of these as half, the other will also become half, right? So the final answer will become the current will also become half, right? The current will also become half. One more question. Let's say question here is why are coils of toasters and electric irons made up of alloy rather than pure metal? So for that, look into this. We know that if the resistivity is high, right, you should know first of all that alloys have greater resistivity, right? Uh, Alloys have greater resistivity than that of the metal from which it is made, right? So that's the reason why the coil gets heated up earlier, right? So coils are made up of, toasters are made up of alloy. So first reason is alloys have greater resistivity. I mean to say the resistivity of alloy is greater than the metal from which it is made. And therefore it becomes hot. And the second reason here is the second reason you can understand from here. Yeah. So the second reason is that alloys do not get oxidized easily at high temperature. You know, if I take a metal, say copper, at high temperature, it will get oxidized to become copper oxide as you have studied earlier. But these alloys do not get oxidized. So two reasons. Number one, alloys do not get oxidized at high temperature. And the second is that alloys have greater resistivity. In this question, it says the resistance of a metal wire of length L. Well, before we read the question, I should tell you first, this question is actually based on this formula that R is equal to rho, that is resistivity L over A. So what we know here that let's say if I take a wire here and things that you need to understand, it's area of cross section. And you know that area of cross section is what? Cylindrical wire is circular, right? So that means it is, we should also consider about the area of cross section, which is pi r square. Well, pi r square, I said, and L being the length here. All right. So now read the question as we read. It says the resistance of a metal wire of length 1 meter. So I know that the length is 1 meter and the resistance is 26 ohm. Temperature will not have any significance in this question, although the resistance depend upon the temperature. If the diameter of the wire is this much, so as I said, we are looking for this area, so I need R. So radius will be what? Half of this, right? So 0.3 over 2. And it's in millimeter, so we need to convert them in meter by multiplying with 10 raised to the power minus 3 or say dividing by 1000. Okay, we got the sin length. The next is to read it further. It says resistivity of the metal at that temperature is what we have to get. So as I said, you have to find resistivity. So I'll be isolating this rho from here, right? So from here, I can see what is rho is equal to. Let's see if I write rho. So it will be by cross multiplication R multiplied by A divided by L. And as I place the value resistance, which is given as how much? It is given as 26. Area, as I said, is pi r square, and pi is what? 22 by 7, or let's take 3.14. That's better to calculate. Into r square, square of this. Let me write this as 3 by 20. So it's going to be 3 by 20 multiplied by, we need a square of this, right? So I'll write this twice, 3 by 20, and we'll also be writing 10 raised to the power minus 3 twice. Now, what can be reduced here? I can write it 10, and this will be what, 13? Yeah, that's right. This again becomes 10 by dividing it to 1.57. So now our rho is what? Is 13 into 1.57 into how much is 9? This is 9. Yeah, that's 9. And let's club these together. This is what, 10 raised to the power minus 6. And there is 2 more. So 10 raised to the power minus 8. Minus 8. Am I right? This is what, 10 raised to 100, and above is 10 raised to, yeah, I'm right. So now I'll do the further calculation. This is what? This is 1.57, right? This is 1.57. The only calculation that we have to do is for this. So if what is 13 into 9 is 117, right? So 117 into 1.57 is what I'm using calculator. So this you have to do in the exam, 1.8369 into 10 raised to the power minus 8. Now writing in the standard form, as you know that on shifting the decimal 2 places left, right? Here, I have to increase the power by 2. So the resistivity will be what? 1.83, or I should write 84, right? Rounding of this up to 2 decimal place, 10 raised to the power minus 6 ohm meter. So this is going to be the answer. The resistivity is what we have to calculate, and we got this as 1.84 into 10 raised to the power minus 6 ohm meter. That's how we'll do this question. In this question from the chapter resistivity, before we read the question, let me first explain you the concept on which it is based on. Now, the concept here first is the relation, right? What we know that R is equal to rho. Rho is what? Resistivity L over A. Well, R stands for the resistance. And here L stands for the length of this conductor. Let's say I took this conductor, and A is the area of cross section. And as you know that if you look into this, the section of, or the cross section area is what? A wire is always taken as cylindrical in shape. So its area should be, area of cross section is pi r square. Now this is something that we have to keep in mind while doing this question. Now, if I read it, it says that there is a wire of diameter 0.5 mm. So we know that we are concerned about the radius. So I can say the radius will be half. 0.5 is what? 0.5, or let's say if I write down the diameter only, diameter is what? 0.5 mm, right? And I should multiply this by 10 raised to the power minus 3 to convert in meter. This is because 1 meter is 1000 millimeter. And if I write down the radius, it will be half of this. So half of this is what? 0.25, right? 0.25 into 10 raised to the power minus 3 meter. Now, I will simplify it further. This is because the calculation involved can be difficult at times. So that's why I first simplified it here only. The radius we got, and the resistivity is how much? 1.6 into 10 raised to the power minus 8. So the resistivity, which is rho, right? Which is how much? The resistivity is denoted by this rho. It is 1.6 into 10 raised to the power minus 8 ohm meter. Now, as I read the question further, it says, what will be the length of the wire? So we have to find out the length of this wire. So any other information we have? No, we have to find the length. Yeah, the resistance is given 26 ohm, right? Oh, sorry, 10 ohm, right? Not 26 ohm. The resistance is given 10 ohm. This is 10 ohm. So I should write down the resistance here. R is equal to 10 ohm. Now I'll be using this information to find the length of the wire. So the length of the wire is what we have to calculate. That's question mark. Let's keep this information in a box. Now from here, I'll be isolating L. So L will be what? R multiplied by A, that divided by rho. So let's plug in the value R, which is given as 10 ohm. Area, which I said is pi r square. So pi is what? 3.14 and r square. And how much is radius? Radius is this. So I can write this as what? 1 by 4 over 1 by 4, that multiplied by 10 raised to the power minus 3 twice, right? Because as you can see, it is square of this. So square of this, that's why I'll be multiplying 10 raised to the power minus 3 once again. That divided by rho. And how much is rho? Rho is this. So dividing, I can divide it over here, or let's say if I divide like this is 1 point. I'll write 60. Soon you will understand why. So now check here, we have equal decimal place. So I can cancel this decimal or remove this decimal from these two. This is how much? 2 times, and this is 5 times. This 2 with 157. So now what we are left with? 5 into 157, right? And that divided by 4 and 4, and there is 160 as well below. Now check for the other part. That means what happened to this? This was 10 raised to the power minus 8, right? Okay. So if I look into these values, right? Look into these are exponential form, and I can write this as what? This is 10 raised to the power minus 6 divided by this. So you can do some mind calc, like 10 raised to the power minus 6 divided by 10 raised to the power minus 8. If you apply laws of exponent, is going to be what? 10 raised to the power 2, right? Minus 6 plus 8. That's what I'm doing here. I'm writing this as 10 raised to the power 2, and 2 is what? 100 only. So this is 100. Okay, I can cancel this zeros here. And further, I can cancel this by 5 times, and this will by, say, 8 times. Okay. The rest calculation involved is 5 into 5. That's 25, right? So 25 multiplied by 157. That comes out to be 3925 divided by this is how much? 32. 32. So if I divide, I'm getting this as L is equal to 122.65 meter. So you can say that this should be our final answer here. That is the length. Now there is one, if I see the later part, it says how much does the resistance change, right? If the diameter is doubled. So let's once again make a wire. This being the wire, and you know that this cross section area is circular in shape, right? It is circular in shape. So that means the area of a circle, which is pi r square. From here, we can see that area is directly proportional to the square of the radius. So it should be directly proportional to the square of the diameter as well. Okay. And the diameter is doubled. So I can see that from here, right? Doubling the diameter will make area what? 4 times, as there is a square relation. Area will become 4 times. Area will become 4 times. And they are asking for the change in resistance, right? So we know that resistance is inversely proportional to the area. So let's correlate these two. On changing the diameter to double, area becomes 4 times. And from here, what you can see that resistance is inversely proportional to area. So the resistance will become 1/4. Resistance will become 1/4. Well, we don't have to actually show everything in the exam. You may simply write down the end answer or whatever is just visible. This is what you have to write down. This is important. You have to write down this, and you have to write down that area is inversely proportional to the square of the, sorry, directly proportional to the square of the radius. So information number 1, you have to write, second step, and this step. This is how we will determine the answer for this.